We were promised a predictable cosmic event, but this interstellar traveler just shattered every expectation. Something is wrong. On October 29th, 2025, as the wanderer from another star system, designated 3I/Atlas, made its closest approach to our Sun, it defied all predictions. The event that unfolded has left the world's top astronomers in a state of collective confusion. What they are learning is forcing a complete re-evaluation of what we know. This isn't just another space rock. This is an ancient messenger from the void between stars, and its behavior is anything but normal. The deeper we look, the more perplexing it becomes. Let me show you what's unfolding in real time, because what happened in recent days has upended our fundamental assumptions. As 3I/Atlas reached its point of closest solar passage, its activity didn't just intensify, it detonated. The object's luminosity didn't follow a gentle curve. It skyrocketed, doubling its rate of brightening in an instant. Astronomers from the Loeb Observatory and the U.S. Naval Research Laboratory recorded this anomaly live, and they had no ready-made answer for the phenomenon. Consider the journey. This entity has drifted through the interstellar medium for potentially billions of years. It has endured conditions we can scarcely model. And now, near our Sun, it erupts with an intensity no simulation foresaw. Why? Spectral data uncovered a critical clue. The light from the object shifted notably towards the blue end of the spectrum, even bluer than our Sun's own light. This specific blue tint signals the presence of carbon-based compounds and emetogen. These are the telltale signs of ices turning directly to gas. But here's the truly staggering part. Radio telescope measurements showed that in the mere fortnight before its solar close approach, 3I/Atlas was ejecting water at a rate of roughly 5.7 times 10 to the 28th molecules every second. That is 40 times the volume it was losing just 4 weeks prior, a 40-fold increase. One researcher described it as a cosmic geyser, unleashed at maximum power. You might assume this is standard for comets. They warm up, they outgaze, they brighten. Basic textbook stuff. Except 3I/Atlas is not obeying the textbook. The speed of the change is off. The sequence is off. Nothing matches the behavior of comets born in our own solar neighborhood. Here's where the plot thickens. Orbiting observatories like SOHO, Stereo A, and the new GOES 19 satellite, all fitted with special sun-blocking coronagraphs. Image 3I/Atlas during this pivotal phase. What they recorded was odd. The visitor showed up as a faint, distinctly stretched out smudge. But the real enigma, it had no discernible dust tail. Zero. Just this elongated gleam, completely lacking the classic dusty trail that comets always paint across the sky. What does this imply? One leading theory suggests that carbon dioxide gas was initially venting from the object at a distance of about 3 times the Earth-Sun distance. This CO2 may have been cooling the nucleus surface, forming a kind of insulating blanket that stopped water ice from vaporizing. Then, a shift occurred. That protective layer vanished, and when it did, the underlying water ice was abruptly subjected to unfiltered solar radiation. The outcome? A cataclysmic surge in brightness and outgassing. But there exists another, more profound possibility. And this is where some in the scientific community grow uneasy. The very makeup of 3I/Atlas's core could be unlike any we have ever cataloged. Do not forget, this body did not originate here. It formed around an alien sun, within a different stellar nursery, under different chemical circumstances. What if its internal architecture is completely foreign to our experience? What if there is a component within that nucleus that remains beyond our current comprehension? The James Webb Space Telescope has been tracking this visitor, and its findings pile another mystery on top of the existing ones. Webb's sophisticated infrared sensors showed that this comet has been fundamentally reshaped by eons of exposure to cosmic rays. We are referring to galactic cosmic rays, high-energy particles that flood the emptiness between stars, relentlessly pummeling the object's surface for ages. Research led by Roma Maggiolo indicates these rays have irrevocably changed the physical and chemical nature of 3I/Atlas. Computer models propose that cosmic rays have penetrated between 50 and 65 feet deep into the comet's exterior, forging what experts now term a deep, irradiated crust. This crust no longer represents the primordial stuff from its native star system. It has been irradiated for so long it has mutated into an entirely new substance. This object is now a relic of its journey, not its origin. Here is the fundamental shift in thinking. Scientists had hoped that interstellar objects like 3I/Atlas would provide a clear portal into other star systems, that we could dissect these travelers and understand the conditions around faraway suns. But if the new research is correct, what we are analyzing is not a pristine sample from another star. It is a heavily modified radiation process shell, fundamentally altered by its epic voyage through the galactic depths. This forces a pressing question. What lies beneath that irradiated crust? What pristine material from its original birthplace might still be hidden in the object's heart? And here is a detail most audiences are unaware of. Professor Avi Loeb, the former head of Harvard's astronomy department, has officially petitioned NASA to make all scientific data on 3I/Atlas publicly available. Why take that step? What does he suspect is contained within that data that has not been disclosed? The behavior of 3I/Atlas after its close solar pass is now the target of fierce scientific focus. Researchers openly concede they cannot predict the next phase. Will the brightness keep climbing? Will it abruptly diminish? The astronomers noted in their reports that the comet's evolution following perihelion might be just as bizarre as the outburst that came before. Potentially more so. And that profound uncertainty is what makes this moment so pivotal. We are witnessing, in real time, an envoy from another solar system behave in ways that defy our models. At its closest approach, 3I/Atlas achieved a visual magnitude around 9. That is sufficiently bright to be seen with modest backyard telescopes if you had the precise coordinates. But there was a catch. Its position was so extremely close to the sun in our sky that observing it from the ground during that critical window was virtually impossible. We depended entirely on space-based coronagraphs to witness the event, and what they displayed was an entity that looked nothing like a standard comet. The pictures showed this stretched, luminous shape without the anticipated dust tail. Instead, the emission appears to be almost entirely gaseous. The hydroxyl signature, the fingerprint of water vapor streaming from the comet, was picked up by NASA's Swift telescope, but the absence of visible dust. That is the anomaly. Comets generate dust. It is what creates their magnificent tails. So where is the dust from 3I/Atlas? One hypothesis is that its composition is fundamentally ice-dominant, with minimal rocky material to form dust. But that fails to completely account for the explosive brightening. Another possibility, and this is where certain experts become visibly unsettled, is that the object's internal geometry is unclassifiable by our current systems. Now, let's examine the James Webb Space Telescope's revelations, because this is where the narrative veers into realms that test our core assumptions about interstellar wanderers. Webb observed 3I/Atlas back in August before its solar encounter. Its powerful infrared spectrometer examined the light emanating from the comet, studying the specific wavelengths that reveal its molecular makeup. The information confirmed an earlier suspicion. This comet is abundant in carbon dioxide. Remarkably so. But more critically, Webb's analysis demonstrated that the outer layers of this object have been fundamentally transmuted by cosmic radiation. Here is the implication. Our solar system exists within a protective envelope called the heliosphere, generated by the solar wind flowing outward from our sun.
This heliosphere shields us from the majority of galactic cosmic rays, those high-energy particles originating from supernovae and other violent galactic events. But in the space between stars, no such protection exists. Objects meandering through the interstellar void are subjected to the full, relentless force of cosmic ray bombardment for millions, even billions of years. We are not looking at a visitor, but a transformed relic. This mystery is far from over, and we will be here to follow every new discovery. If you want to stay updated on this and other cosmic puzzles, make sure to support the channel. Please hit the like button and subscribe to Lines of Thought to help us bring you more content that explores the furthest reaches of knowledge. Astronomers prepared for a predictable event, but what this interstellar object did next has left every expert speechless. Computer simulations created by Maggiolo's research group, building on prior work with solar system comets, modeled the effects of prolonged cosmic ray exposure on icy and rocky bodies. The results revealed that after nearly 1 billion years of irradiation, a full metamorphosis occurs. The surface layers evolve into an entirely new substance. Carbon monoxide transitions into carbon dioxide. The ice's crystal lattice rearranges. Molecular connections fracture and reassemble into novel forms. This process yields a hardened layer penetrating about 50 to 65 feet deep into the comet's core. A shield of radiation-altered matter that no longer reflects its original state from its home system. And here is the disturbing reality. We have no true measure of this layer's depth. We cannot predict whether solar warmth will wear it down to uncover pure material below, or if the whole entity has been converted entirely. Maggiolo emphasized that researchers must factor in weathering effects when examining 3I/Atlas. One cannot simply treat it as an untouched specimen from another sun. You are observing something forged by the brutal conditions of the galactic void. Yet he also offered a positive perspective. He noted that 3I/Atlas stays profoundly intriguing despite this hurdle because if we can decipher how the irradiated shell developed, and if we can contrast pre-perihelion data with post-perihelion findings, when solar heating may have uncovered inner strata, we could still catch a view of the primordial composition. That is the focus of scientific anticipation now. The comet has swung past its closest solar approach. It is now receding from our star. And in the coming months of November and December 2025, as we speak, it will re-emerge into Earth's view while journeying outward from our planetary neighborhood. This is our critical chance. This is when we may determine if stellar radiation has scraped off sufficient irradiated crust to expose what lies beneath. However, another development is underway. An element that challenges the conventional story of a typical comet. Suzanne Falsner, scholar at Forschungszentrum Jülich in Germany, has put forward a revolutionary concept regarding interstellar visitors like 3I/Atlas. She proposes these bodies might be more than mere space relics. They could be the embryonic cores of planets. Her digital models indicate that infant stars encircled by their formative rings of gas and dust might trap countless such objects as they voyage across the cosmos. And once near, these entities, already spanning hundreds of meters, could act as the central anchor around which worlds accumulate. This resolves a persistent puzzle in planet formation science. We understand that planets assemble via accumulation, tiny bits clumping into progressively bigger masses. But a conceptual hole exists. Computational models demonstrate that once items grow to roughly a meter across, the turbulent setting of a young star's disk should make them smash and fragment instead of coalesce. So, how does one progress from boulder-sized fragments to entire planets? Falsner's solution is elegant. You do not begin with meter-scale stones. You commence with interstellar objects that are already substantial enough to pull in matter through gravity and initiate the world creation mechanism. The interstellar medium supplies preformed kernels for upcoming planetary generations. And here is the crucial point. Her simulations indicate this mechanism operates particularly effectively around heavyweight stars, those more massive than our Sun, which would clarify why gas giants similar to Jupiter are often detected orbiting larger stars, even though the planet-forming disks around such stars persist for nearly 2 million years, a duration too brief for classical planet formation models to function. Therefore, when you gaze upon 3I/Atlas, you are not merely seeing a comet. You are possibly witnessing the sort of body that might have matured into a planet had it been snagged by a newborn star eons ago. You are seeing a foundational piece of civilizations that never assembled, and that reshapes the whole framework of our observations. But let us refocus on current events, because the most captivating dimension of this tale is not solely what we have learned. It is what remains unknown. The path of 3I/Atlas is peculiar. It is speeding at beyond 130,000 miles per hour relative to our solar system, following what watchers have called a remarkably level and direct route. This is not the erratic, winding course anticipated from an object that originated within our solar system and has been molded by planetary pulses for ages. This is a path that proclaims, I am from elsewhere, and I am merely transiting. Certain calculations propose 3I/Atlas might be about 7 to 12 billion years in age. That would place it roughly 3 billion years senior to our entire solar system. Ponder that. This entity was present before our star ignited, before Earth took shape, before any known planet existed. It has been cruising through the galaxy since an era when the Milky Way appeared utterly unlike its current form. What scenes has this object witnessed? What realms has it traversed? What solar systems did it glide past in the blackness? Never quite near enough to be caught, but sufficiently close to be affected by their emissions, their stellar dusts, their cosmic settings. We recognize it originated from somewhere in the galactic intricacies, like the crimson primordial. But we do not know its formation site, which star it circled, or what became of that star. We do not know if it was flung out from a young planetary family by the gravitational tussle of emerging gas giants, or if it simply condensed and void between suns and roving pursuits. What we are sure of is that at this exact instant, 3I/Atlas is departing from our sun, venturing back into the obscurity, and we possess a narrow opportunity to collect as much information as feasible before it vanishes from sight permanently. Once it departs, we will never encounter it again. This is a singular moment, and that leads us back to Avi Loeb's appeal to NASA. Professor Loeb has been outspoken on the necessity for openness concerning interstellar objects. He was a prominent advocate for rigorous scientific scrutiny of Oumuamua, the first verified interstellar guest, which traveled through our realm in 2017. Loeb proposed then, and still holds, that we ought not to reject unusual hypotheses when faced with anomalous data. He contended that Oumuamua's stretched form, its unforeseen speed increase upon exit, and its absence of typical comet phenomena were all irregularities that warranted deep study instead of hasty dismissals. Now, with 3I/Atlas, Loeb is urging NASA to disclose all scientific information to the wider research world and the public. His reasoning is clear. This is a body of immense scientific value. It is only the third confirmed interstellar traveler we have ever spotted. The information gathered by NASA's equipment, by the Swift telescope, by SOHO, Stereo, and GOES-19 constitutes humanity's prime opportunity to comprehend what interstellar objects truly are. That data should not be hoarded. It should be accessible for autonomous scrutiny by investigators globally. But an implicit inquiry lurks beneath Loeb's plea. What precisely resides in that data? What has NASA detected that has not been shared openly? Are there readings, spectral patterns, or conduct trends that do not neatly align with public statements and initial reports? The research world is split on how to decipher 3I/Atlas. Some analysts are content with the interpretation that it is simply a comet with a strange makeup altered by cosmic rays acting in manners we have not previously observed, because we have never examined the interstellar comet so intimately. They highlight the carbon dioxide, the water vapor, the molecular indicators that all signal this is a comet, albeit in an odd way. But others are more skeptical. They underscore the irregularities, the eruptive brightening that contradicts projections, the absent dust trail, the impeccably straight course, the chance that its internal architecture is basically unlike anything in our celestial backyard. And they murmur softly in academic articles and symposium talks. What other rationale could account for these facts? No one voices it openly. No one desires to be the researcher who leaps to inferences without proof. But the doubts persist, suspended in the vacuum like the comet's own shimmering weight. What if this visitor is not wholly natural? What if there is an aspect of its makeup, its framework, or its actions that implies it is beyond a simple aggregate of ice and stone that has been meandering through the cosmos for millennia? Here is why that notion is so disquieting. We might be staring at a relic from a time before our sun was born. If you found this exploration of cosmic mysteries compelling, support our journey into the unknown. Please like this video and subscribe to Lens of Thought for more content that challenges everything we know. Scientists thought they understood cosmic visitors, but this interstellar object's behavior has shattered every model and left researchers in disbelief. We lack any established paradigm to address this enigma. Our complete astronomical knowledge regarding comets, asteroids, and objects from beyond our solar system rests upon assumptions of natural origins. When we examine light signatures, we detect carbon dioxide and water vapor, and we label it a comet. We observe an elongated form and assume it's a shard from some ancient planetary smash-up. We trace its path and compute gravitational engagements with far-off star systems. But suppose the indicators we've been educated to read actually possess several potential interpretations. Suppose certain observations align equally with both naturally occurring and intelligently crafted sources. How could we possibly distinguish between the two? This isn't about proclaiming 3i/Atlas to be something extraordinary. This is about recognizing that our collective experience with interstellar objects amounts to merely 3 instances. Oumuamua, Borisov, and now 3i/Atlas. 3 specimens from among the possible billions or trillions of such entities adrift in our galaxy. We're formulating sweeping generalizations about an entire category of cosmic events based on a trifling sample. That isn't rigorous science. That is, at most, initial reconnaissance. And each of these 3 has delivered its own set of puzzles. Oumuamua accelerated in a manner inconsistent with simple outgassing. Borisov appeared fairly conventional, yet hailed from an alien stellar neighborhood with distinct chemical fingerprints. And now 3i/Atlas is illuminating explosively, shedding water at staggering volumes and defying our predictions for irradiated comet behavior. Perhaps all 3 are merely natural bodies with quirky attributes. Perhaps the cosmos is infinitely more varied than we've imagined, and each interstellar guest will unveil new truths about the diversity of galactic environments and genesis mechanisms. That is the most straightforward answer, and it is likely true. However, the violent intensity of 3i/Atlas's flare-up, its exact timing, how it occurred precisely at perihelion, that continues to bother certain investigators. Because a distinction exists between the oddly explicable and the oddly suggestive of concepts we haven't yet entertained. Let's discuss the future, because the saga of 3i/Atlas is nowhere near concluded. As the comet retreats from the sun, it will stay visible during November and December. Astronomers globally are aiming their instruments toward it, gathering spectral information, monitoring its luminosity, noting any shifts in its activity. The burning question on everyone's mind is straightforward. Will the outgassing diminish now that solar influence wanes? Or will an unexpected event occur? The astronomers specifically mentioned that the post-perihelion phase might prove equally bizarre as the pre-perihelion eruption. What was the implication behind that statement? What are they anticipating? Or, more precisely, what are they fearing could transpire? One scenario is that the comet will dim predictably, reduce solar heat-slowed sublimation, brightness fades, and 3I/Atlas turns into a faint dot, slowly vanishing into the void. That would be the ordinary outcome. Another scenario is that activity persists or even intensifies. If something lies within the core, some volatile substance now uncovered by the wearing away of surface layers, it might keep emitting gas despite increasing distance from the sun. That would indicate a stark contrast between interior and exterior composition. A third scenario exists that nobody wishes to vocalize. What if the conduct alters in a fashion wholly inexplicable by solar thermal dynamics? What if the activity displays a regularity hinting at innate mechanisms instead of external warming? What could that imply? The Martian rovers, Curiosity and Perseverance, actually enjoyed a special chance to watch 3I/Atlas from their location on the Red Planet. Their viewpoints offered a unique angle, a different line of sight that might expose details hidden from Earth. The findings from those watch sessions haven't been completely divulged. What did they capture? Here's a fact few appreciate. The comet approached so near the sun that the solar wind, that flow of charged particles emanating from our star, would have engaged directly with its coma, the gaseous and dusty envelope around the nucleus. That engagement produces phenomena. We can detect plasma irregularities, magnetic field warping, particle speed increase, and these phenomena can inform us about the comet's makeup and architecture in methods beyond simple light analysis. NASA's Stereo mission, expressly crafted to examine the sun, its impact on nearby space, obtained imagery depicting 3I/Atlas interfacing with the solar wind. Those pictures showed formations within the coma, imbalances in gas spread, configurations that imply intricate forces in action. But deciphering these configurations demands proficiency not only in comet science, but in plasma physics, magnetohydrodynamics, and the turbulent conditions near the sun. This is why the appeal for data openness holds significance. The greater the number of experts examining this information, the more viewpoints applied, the higher our odds of grasping the actual situation. Perhaps one team will spot something others overlook. Perhaps an external assessment will uncover a configuration that transforms the whole narrative. Science achieves optimum results when it operates transparently, when information is circulated, when peculiar findings face thorough inquiry instead of swift rejection. And 3I/Atlas is sufficiently peculiar to warrant such examination. Now, let's tackle a topic circulating in digital conversations and hobbyist circles. Some individuals have observed that the synchronization of 3I/Atlas's outburst with its perihelion passage appears excessively exact. Natural events tend to be untie-dye, chaotic with progressive shifts rather than abrupt jumps. So why did the luminosity spike occur precisely then? The conventional reasoning is that a threshold was crossed, as the comet warmed. It hit a pivotal temperature, where the vaporization rate jumped suddenly. The shielding carbon dioxide layer vanished at a particular moment, and once gone, the underlying water ice faced exposure simultaneously, causing the swift brightness. That is reason. That aligns established principles. But an alternate reading tracks some. What if this entity was engineered to become active at a specific stellar proximity? What if the flare wasn't due to passive warming, but to some built-in procedure initiated by closeness to our sun? Before you reject this as fantasy, reflect on this. We have already dispatched probes to other worlds that activate under particular circumstances. We have constructed satellites that power on when they sense solar radiation exceeding set thresholds. The idea of a system activated by a boundary is not strange. It is elementary design. The issue isn't whether such a thing can exist. The issue is whether any proof indicates 3I/Atlas is not a natural body. And the truthful reply is we lack sufficient evidence to eliminate any possibility definitively. What renders 3I/Atlas especially fascinating is its sheer bulk. Preliminary calculations propose this object possesses a mass near 33 billion tons. That is immense for a comet. Most comets we see from our own solar neighborhood are far lighter. The core of Halley's Comet, for instance, is approximated at about 22 billion tons. So 3I/Atlas considerably heavier than one of history's most celebrated comets. Now, mass by itself signifies nothing odd. Bigger things are found all across the solar system. But when coupled with the other irregularities, the tremendous speed, the violent gas release, the uncommon flight path, it contributes another piece to an expanding catalog of traits that make this object exceptional. And then there is the velocity. 130,000 miles per hour may not seem amazing in astronomical context, but it denotes a particular energy condition. This object is moving swiftly enough to break free, not only from our solar system, but to voyage among star systems over billions of years. It has been in motion for so long that the star where it began might have already died. That star could have left the main sequence, expanded into a red giant cast off its external shells, and condensed into a white dwarf. All while 3I/Atlas was meandering through the emptiness. Consider that voyage. 7 to 12 billion years, if age approximations are accurate. This entity has been journeying since before multicellular life arose on Earth. It traversed zones of space we can only hypothesize about. It endured meetings with innumerable star systems, gravitational tugs from massive bodies, irradiation from unidentifiable origins, and it emerged from all that unscathed, still unified, still identifiable as a distinct entity, and not a scattered debris field. We are looking at a relic from an era before our sun ignited. If this journey into the cosmic unknown captivated you, help us explore further. Please like this video and subscribe to Winds of Thought for more content that questions reality itself. What if this interstellar object isn't just a random space rock, but something far more intentional? That survival alone is astounding. The likelihood of any entity enduring interstellar voyages across billions of years should be minimal. Encounters with other bodies, gravitational disturbances, radiation-induced decay, all pose significant risks. Yet 3I/Atlas remains, seemingly whole, operating in a manner that indicates remarkable cohesion despite its extreme age. The irradiated shell, identified by the Webb telescope, could indeed hold the key. That 50 to 65 foot deep barrier of radiation-processed substance might function as defensive plating, safeguarding the inner core from additional harm, preserving its fundamental form. It is a casing molded by eons of cosmic ray bombardment, tougher and more resilient than the untouched ice below. In a way, the voyage itself enhanced 3/Atlas's endurance. But this becomes fascinating from a design viewpoint. Imagine crafting a scout to journey among star systems, to persist in the brutal void of interstellar space for millennia. What would you incorporate? Shielding against radiation would be essential. Structural soundness to endure tiny particle strikes. A configuration capable of managing severe temperature swings, and likely largely inert, not needing operational mechanisms for most of the trip, only awakening when certain criteria are met. A radiation-formed crust would fulfill several of these roles. It would guard the inside. It would offer robust support. It would develop naturally in the surroundings, demanding zero upkeep. And if something lay beneath, something requiring dormancy until activated by stellar proximity, that shell would preserve. Now, I am not claiming that is what 3I/Atlas represents. I am noting that if you examine the traits we have documented, the antiquity, the bulk, the shielding layer, the threshold-based activation, you are seeing attributes that also align with an engineered artifact intended for interstellar travel. That demonstrates nothing. It simply implies we must be meticulous in our scrutiny. This is the purpose of the scientific approach. You do not begin with answers.
You collect information. You evaluate theories. You seek methods to differentiate between alternative interpretations. And currently, we require additional data. The observations arriving in the coming weeks will be pivotal. If 3I/Atlas dims as expected, if its conduct aligns with improved models of irradiated comets affected by solar warmth, then we will possess a solid natural rationale for all we have witnessed. The oddities will be clarified as consequences of peculiar yet comprehensible makeup and historical exposure. But if the behavior persistently diverges from forecasts, if there are rhythms in the activity that do not sync with solar proximity, if the spectral information discloses compositions or frameworks that contest our grasp of natural comet genesis, then we must broaden our conceptual scope. We must contemplate ideas that presently appear improbable. And that unsettles many researchers because once you begin considering hypotheses outside the standard box, you invite critique, charges of conjecture, branding as marginal or hyperbolic. Yet that unease should not stop us from pursuing the evidence wherever it guides us. Loeb has been emphatic on this. He has consistently contended that to boo around examining non-natural sources for anomalous objects is itself unscientific. Science should be impartial regarding results. You suggest theories. You examine them against facts, and you adhere to the outcomes. If a synthetic origin theory can be examined and disproven, then it constitutes a legitimate scientific theory irrespective of the discomfort it provokes. The difficulty is determining which observations would genuinely separate natural from artificial beginnings. What would we anticipate observing that differs? Which metrics, which rhythms, which markers would be conclusive? For a natural comet, we would anticipate activity to directly correlate with solar heating. We would anticipate the composition to reside within recognized parameters for ices and rocks created in protoplanetary disks. We would anticipate structural differences to be arbitrary mirroring chaotic formation procedures. We would anticipate the path to display minor fluctuations from gas emissions that align with the direction and strength of physical jets. For something engineered, we might anticipate exact threshold behaviors, activity that activates or deactivates at particular conditions instead of evolving steadily. We might anticipate uncommon symmetry in form or makeup. We might anticipate course adjustments inexplicable by passive gas release. We might anticipate radio signals at frequencies indicating pattern modulation rather than natural plasma activities. Have we searched for these aspects? Have we performed the examinations that would enable us to discriminate between these scenarios? That is what Loeb is urging NASA to supply data for. Allow the scientific collective to inspect everything. Permit autonomous investigators to see patterns. Ensure the evaluation is as all-encompassing as feasible, because here's the truth. We exist in an epoch of cosmic importance. For the initialists and chronicles, we possess the tools to identify, follow, and scrutinize objects from other star systems. We can direct our most sophisticated telescopes at these guests and accumulate information that would have been unattainable nearly 2 decades prior. James Webb Space Telescope, deployed only a few years back, is providing us perceptions, composition, and architecture of objects of unparalleled detail. Our array of orbital observatories delivers uninterrupted surveillance that terrestrial telescopes alone can never accomplish. This is the zenith of interstellar object investigation, but it is also a transient opportunity. These objects transit swiftly. 3I/Atlas will vanish within months, fading back into the immense void between the suns. We might not encounter another interstellar guest for years or decades. Each one is invaluable. Each one is a chance we do not squander. And that is why the explosive illumination is significant. It is why the absent dust trail is significant. It is why the absent dust is significant. It is why each peculiarity, each unanticipated action, each divergence from our paradigms warrants earnest consideration, because we are not merely examining a comet. We are compiling information that can revolutionize our comprehension of what dwells in interstellar space. Ponder the ramifications if interstellar space is populated with entities like countless multitudes of them drifting among the stars, bearing within them the chemical imprints of remote stellar systems, perhaps even transporting the foundational elements of planets not yet formed. The galaxy transforms into an immense sea of potential, with primitive substance perpetually in flux, perpetually reallocating itself across light years. But ponder the ramifications of even a tiny portion of those entities for something distinct. If amidst the innumerable natural comets and asteroids roaming the gloom, there also exist relics, scouts, creations dispatched by societies that thrived millions or billions of years ago. What would that signify for our understanding of cognition in the cosmos? What would that signify for our role in the cosmic narrative? We have hunted for radio transmissions from the stars. We have sought laser beams for constructive frameworks around distant suns for any indication that we are not solitary in this enormous universe. But perhaps we have been searching in the incorrect location. Perhaps the proof is not out there among the stars. Perhaps it is here, traversing our own solar system, camouflaged as natural objects, because that is precisely what they are composed of. Interstellar probes would not resemble vessels from sci-fi. They would resemble stones, like ice, like comets. They would assimilate. And the sole method we would discern the disparity is via meticulous, exhaustive assessment of their conduct and composition, which returns us to the data, which returns us to openness, which returns us to the essential query of whether we are being as comprehensive as we ought to be in probing these objects. The upcoming weeks will reveal much. As 3I/Atlas recedes from the sun as we persist in tracking its luminosity, its spectrum, its route, we will assemble more fragments of the mystery. Perhaps those fragments will coalesce into a distinct portrait of an odd but completely natural comet. Perhaps they will disclose patterns that challenge our present understanding and compel us to widen our theories. Or perhaps, simply perhaps, they will demonstrate something we did not foresee. Something that compels us to doubt our presuppositions about what is feasible, about what exists out there in the blackness, about whether we are as isolated as we have perpetually assumed. One aspect is definite. We are observing. At this very instant, telescopes across the globe and in orbit are fixed on 3I/Atlas. Scientists are deciphering spectra, computing paths, simulating internal configurations. Amateur stargazers are exchanging observations, comparing findings, contributing to a worldwide endeavor to comprehend this visitor. The data is mounting. The image is sharpening. And whatever we uncover, whatever the resolution proves to be, it will alter something about our cosmic perspective. Because every interstellar object instructs us anew. Every guess from the gloom brings with it knowledge we could not acquire otherwise. Every aberration is a chance to hone our theories, to examine our presuppositions, to extend the frontiers of our awareness. 3I/Atlas originated somewhere. It voyaged for billions of years to reach us. It withstood environments we can scarcely conceive. And now, for a fleeting interval in cosmic chronology, it is here. Near enough for us to investigate, near enough for us to gain insight. It is acting in ways we cannot anticipate, operating in ways that test our models, exposing qualities that oblige us to ponder more deeply about what interstellar objects truly are. The theory is not whether 3I/Atlas is peculiar. It unequivocally is. The theory is what that peculiarity signifies. Is it the peculiarity of a natural cosmos, more varied and intricate than we have acknowledged? Or is it the peculiarity of something else? Something that makes us reassess foundational beliefs about our position in the galaxy. Duration will reveal. The data will reveal. And that is why we require all of it. That is why transparency is crucial. That is why Loeb's appeal to NASA is vital regardless of the ultimate outcome. Because ultimately, this is not solely about one object passing through our solar system. It is about how we confront the unfamiliar. It is about whether we are courageous enough to pursue the evidence wherever it directs, even if it leads to disquieting realms. It is about whether we are prepared to pose challenging questions and embrace ambiguous answers. 3i/Atlas is still out there retreating from us at over 100,000 miles per hour, conveying its mysteries back into the darkness. But for now, for these invaluable weeks, while it remains detectable, we have an opportunity to learn, to watch, to query, to marvel, and maybe, just maybe, to unearth something that transforms everything. The interstellar visitor has appeared, has executed its surprising spectacle, and is now withdrawing. What it departs is inquiries, vital inquiries, inquiries that merit responses. The cosmos is communicating with us through these objects. Are we attending attentively enough to perceive what it is expressing? We are not merely examining a comet. We are decoding a cosmic message. This object challenges everything we thought we knew about space. If this exploration of the unknown resonated with you, support our mission. Please like this video and subscribe to Wings of Thought for more content that expands your mind.